Hello everyone, thanks for joining. So today I'm going to share some experience, some backend development experience I got like for building web services with Kotlin Ktor. So first I'm going to introduce myself. I'm Julien Salvi, lead Android engineer at RETROFIT, Android Google developer expert, and POG organizer. Sometimes I share some interesting stuff on Twitter, so you can check my Twitter account at Julien Salvi. Okay, so we're gonna talk about Ktor today on the server side. So I go to a quick introduction or what is Ktor. Then I'm gonna show you how to set up a Ktor project. The first step, like to have the main part. Then I'm going to detail some of the Ktor features and some nice third-party library to build like a very reliable web service. And then I'm going to share some stuff about sharing some code between your backend application and your client application. Okay, so first an introduction to Ktor. So Ktor is a framework developed and maintained by JetBrains. It was stable since 2018 now, and the latest release is now 1.6.6, and the 2.0 version is in an early access program. So if you want to test it, feel free to apply for the program to test the 2.0 version. So Ktor was designed as an asynchronous framework for building web services, web apps, or clients for your Android application or multi-platform application. And it's all written in Kotlin. So Ktor is a lightweight framework. You can use the feature as you want. There's a lot of core feature in this framework, and you can easily configure them. Ktor is very extensible, so you can configure all of the pipeline and extend what you need. For example, all the module and the feature, you can modify it. Also, the nice thing, if you are interested in some multi-platform stuff, Ktor is multi-platform, so you can use it on mobile, on backend, and web applications. As I said previously, Ktor is asynchronous, so thanks to the core team, you can build like a very strong asynchronous application, and also a very scalable microservices. Okay, so I'm going to show you how you can build like a tiny web service. It's a cooking API. So we're going to set up the main route at the beginning. I'll show you some of the Ktor feature, like content negotiation or data conversion and so on. Then we're going to plug this microservice to a Postgres database, which will run with Docker Compose. We're going to use expose to communicate with that database and query the database. And we will be using Validator for the data validation of the request. And for the shared code part, I'll show you how you can use Swagger to build a very strong contract between your client and your API. Okay, so let's see how you can first set up a Ktor project. So we're going to go in IntelliJ with the Ktor plugin. And if I switch to IntelliJ, so this is a brand new IntelliJ with already the project on. So if I check the plugin right here, go to the plugin, you see that the Ktor plugin is obsolete for like 4 bit now. Let's say, okay, maybe there is something not deprecated. Actually not. The fact is, if you go to the website of Ktor and say, okay, I want to kickstart a new project, they redirect you to this plugin, but unfortunately, just for IntelliJ Ultimate, not Community. So you can still use the deprecated plugin to like at least start up your project, or you can use this nice website, start.ktor.io, to generate like the basic plugins, the Ktor version you want, the engine, and so on. So you can define, okay, I want to run on the latest version of Ktor, I want an AT engine, I want to add some plugins, some authentication, want to add some session, okay, maybe I want some status page, and so on. And then you can export the project, and it will be downloaded as a zip. So that's maybe the only option if you want like to have the latest version of Ktor to kickstart a new project. But for the sample, I'm gonna went back to IntelliJ and just build an old one with the deprecated plugin. So let's build a new project. So I have a Ktor which is obsolete. Okay, we'll have maybe some. Let's say, okay, I want JSON. I don't need authentication. Okay, I'll go for the routing. Yeah, for the first things, that's pretty much it. Okay, go for netty 1.5. Stuck with that for now. Go next. Example. Kotlin KODERS. Kotlin KODERS. Okay. Next. Okay. Kotlin KODERS will be there. Finish. Let's open it in a new window. And that's pretty much it. After the GRADLE configuration, it will be okay. So you have your application here, which has been generated by the plugin. It's a pretty simple application for now. Just an hello world on the base route. And once the GRADLE configuration will be done, I'm gonna demo this small microservice. So synchronization with GRADLE might take a long time. And almost done. Yes, come on. Anyway, so if you have the IntelliJ Ultimate, you can go for the new one, and if you don't, you're stuck with the deprecated plugin, or go with the website. Okay, so let's see if it's done or not. Kotlin KODERS, no. Yeah. I'll be back later. Oh, scanning it. Take too long. Okay, so I'll demo the stuff at the end. So now let's see how you can build your reliable web service with all the validation stuff database. So let's say we want to build like a cooking API. So I want to see some recipes, see the ingredients, or like query a daily specific recipe. So /recipe/the ID of the recipes. So pretty basic, like a common REST API with post, get, delete, and stuff like this. So our Ktor application on the backend side will talk with a Postgres database, and then our Android app or whatever client app will communicate with this backend application. And we're going to share some code between the client and the backend applications. Okay, this is mostly the feature I will be talking about today. So some of the features here are from the core of Ktor, and some of them are third-party libraries. So all the locations, content negotiation, status page, data conversion are from the core of Ktor. And then for the purpose of the microservice, I will use Coin as a dependency injection, logback for logging, expose to communicate with the database, validator for validate all the requests and the request data that come from the request. Maybe we can use Flyway for database versioning, Moshi for the JSON library, and IKRCP to actually have the connection between our application and the database. Okay, so first thing you want to do when you are building a microservice is like to define the root of your API, and we're going to use the locations feature. So it enables you to create roots that are type safe as we evolve in the Kotlin world. So this is pretty nice, like to have type safe roots. Very easy configuration here, and also it supports the basic types like such as int, string, or boolean by default. And of course, as is the REST API, you can define the get, post, patched, and delete method. Okay, so what it looks like. I'm going to define the roots in my API. So I can do two different ways. So this is the way we can do like have some data classes in data classes to have like some granularity for the root. For example, slash recipes will have, for example, a UID to call a specific recipe, and I might want also to get the ingredient of the recipes. So we can like chain all these data classes with the @location annotation, or I can just declare a class or data class like to define the exact root with the parameter I want, a UID, int, a string, or what suits you for your Ktor application. So when I back on the application from the Ktor microservice, so on the module part, I'm gonna install the locations feature. And then I'm going to define the lambda routing and define the recipes route. So I'm going to create an extension function on the route and define all the method I want, like get the recipes, post a new one, update recipes given an ID, or simply deleting the recipe I don't want anymore. And to do so, this is the mostly common implementation you have here. So you can get all the parameters from the root and from the request. So calling call.parameters. If you have all the parameters you want here, and for the post request to get the body, you call.receive and the body you want to process, and to receive multiple part data, for example, uploading a file, you call.receive multipart to handle the data that is uploaded in your application. So as you can see, I was talking about basic types. For example, here it has a UID type, which is not handled by default. So if I run the application like that, it won't compile and be understood by our application, and it might crash. So what we can do about that is about data conversion. So data conversion is again a feature part of Ktor. It allows you to serialize and deserialize a list of values. For example, it can be a date, a UID, and so on. So it can be combined with locations to support new custom types. Again, it's quite simple to configure, and again, it's part of the core feature. So how it works. So on the application module, again, I'm going to install the new feature. So install data conversion, and I'm going to create a converters in order to support the new UID type. So converters is an extension function on the data conversion configuration. And I'm going to convert the UID, so I'm going to implement the two lambdas, which is decode and encode, so to send and receive this new type. So, okay, I'm going to do my stuff, going to handle the new UID as simple as it is on the screen. Okay, so now my roots are there, type safe, and I can put whatever new custom data I want. As it is a REST API, I want to have my response and request in JSON. So I'm going to use here Moshi, like to serialize and deserialize the data I receive from the request and serialize the response I'm going to send to the client. It's a lightweight library, no HTML escaping. You can write your custom adapters, and it fits well with Android. And also it's used by Swagger GRADLE plugin, and I come back to it later. So the latest version of Moshi is 1.12, and it's well maintained by Square. Okay, so now I have my content negotiation, so I can serialize, deserialize responses and requests. Now I want to validate the data I receive from the client. So for example, I receive a post query. Okay, I want to validate that the body is well formed. So Validator is a third-party library, there for data validation. It's a type-safe DSL in order to validate some objects. It can support also suspending function. The validation, some validation can be asynchronous. It has multiple extensions, Spring, Joda, and so on. Okay, so let's say I receive a new step for a recipe. Okay, this is pretty simple. I have a position, a description, which is a string, and a preparation time. Okay, so this is my my object that comes from Moshi. So the deserialized response request. And so I'm going to validate this object in order to say, okay, the position in the post in the step request must be not null and greater or equal to 0, and the description must be not null and not blank. And for example, the preparation time needs to be not null and greater or equal than 0. If one of the validation is broken, it's going to throw the constraint violation exception. So if it's okay, the application won't crash. And if there is a problem, so we are here, I'm receiving the post request. I'm validating this request, but if there is a problem, the application will crash because we are throwing an exception. And what we can do about that, we're going to use the status page feature from Ktor. It's going to allow us to properly handle errors and exceptions in the application. 3 types of configuration for this feature. You can handle exceptions, handle status code, and status file. Again, it's a pretty simple configuration, and it's part of the core feature, so no need to extra third-party libraries. So again, I'm gonna install the new feature and handle the exceptions. So I'm gonna define, okay, I want to handle the constraint violation exception. So I'm gonna define the exception. Okay, if it's from, I'm gonna catch it and say, okay, which property is in violation? So okay, this one, and I'm gonna respond. You can respond as a plain text or the whatever that suits you here. So with the proper HTTP status code. And let's say also if there is an error, I don't want my application to have a big crash. Okay, I'm gonna handle like all the throwable exception. If there is one, I'm gonna say, okay, it's an internal error status, something we want. Okay, so now we can validate and catch exceptions or status code and so on. Let's see how we can actually process the data. So first, we're gonna see how we can set up a Postgres database from Docker with Love. Okay, so how we can achieve that. So we're gonna use is Postgres to persist our data. We're gonna run the PostgreSQL database on Docker. You can also run pgadmin to check that everything's running well and inspect the database. And we're gonna use Docker Compose. Docker Compose is a tool that runs multi-container Docker applications. And it's a classic YAML file to configure. So let's have a look at it. Like pretty straightforward here. You define the version, say, okay, I want to use the Postgres 12 Alpine version. I'm gonna define the database, user, password, and so on. And then it's gonna, we will be able like to run the Docker applications that will hold our Postgres database. So in order like to start the database, we will be able like to do it with the Docker Compose up. If you want to shut down it, Docker Compose down. You can check the volume var active with Docker volume ls. And if you want to remove one volume, for example, okay, I don't want pgadmin anymore. Okay, so Docker volume rm, and you can delete the volume you want. Okay, so on our backend application, so we're gonna use the Postgres library, EKRCP to open the connection, and maybe use Flyway for the migration. Okay, so in our application configuration file, so we're gonna define our database and open up the connection, set up the connection details. So okay, I'm gonna define the route to the database. Okay, defining the user and password to open the database. So in our application, so let's say, okay, this is my database class, whatever. So I'm gonna get the Ocon configuration file, and I'm gonna init also a data source. My Ikari data source will deal with the Postgres database. So I'm gonna open up this and configure this connection. So okay, I'm gonna get the JDBC connection, the user password, and so on. I'm gonna put some configuration here. And then I'm gonna inject this data source with the expose. So I'm gonna create the real connection in order to query my database. So this database object comes from expose, and I'm gonna connect to the data source in order to be able to query my database from the application. Okay, so that we are here and we want to query our database, so we're going to use Expose. Expose is an ORM framework for Kotlin made by JetBrains. So it supports lots of database types, so Postgres, MySQL, H2, MariaDB, and so on. And it has a data source for the GBD connection, for example, here with IKRCP. To query the database, you can go both. If you want to go for DSL, that's fine, or you can go for DAO API. It's up to you. It supports basic and advanced CRUD operation, so we can do whatever we want. Okay, so in order to deal with our database, we're gonna implement and integrate these 4 libraries. So expose core, the DAO, the JDBC connection, the Java time in order to have some date type in our database. Okay, so let's see how we can set up the tables and how we can query the database thanks to expose. So for example, we have a recipe table which contains a title, a description, and a cooking time. Maybe we can add some default value to some attributes. And then we're gonna create a recipe class that will be our entity that we will manipulate this object in order to query our database. So you're gonna have a reference to the recipe table, and so we will be able to manipulate the title, the description, and the cooking time. And let's say with this object, I want also to have access to the steps and the ingredient of a recipe. So I'm gonna have a reference to the step table has been created before, and like that I will be able to get the steps, and same for the ingredients. So we was talking about supporting CRUD operations. So this is how we can create a new recipe. So we take this entity we created just before and call the .new lambda, and you can set the title, the description, and the cooking time, and it will return the created object. Same for read. You can find by ID or find with a custom predicate. And then you can update a recipe. So you find the recipe and update the title, for example. Same thing, but for delete, you call .delete on the subject. Okay, so all these operation have to be done in a transaction. So you can go for a basic one. So use the transaction lambda, and so you can do your operation inside. You can have a nice interoperability with coroutine, so you can create a new suspended transaction. So that's nice for coroutines. And also you might go for a defer transaction with the suspended transaction async, and you put the dispatcher you want. Okay, so we were talking about a Postgres database, some CRUD operation, and PostgreSQL is a relational database. So let's see some referencing here and how we can manage many to one relation. So for example, my step table will have a reference on the recipe, because that's a step for a recipe. And it will have a reference on a video table. So, for example, it might have a video that explaining the step or not. So when I'm defining the step entity, so I'm gonna define, okay, I have a recipe that referenced on the step table.recipe. So like that, I will be able to access the recipe. And if the data is optional, you will be using the optional referenced on your object. And on the recipe side, so I will have access to my steps, which will be using the refers on step table recipe. So like this, you will have access to the data in a relation way. And again, new referencing here, so relation many-to-many. If you are familiar with Room, that's pretty much the same here. So if I want a reference in my recipe entity to get all the ingredients that are for this recipe, and on the other side, in my ingredient entity, I want to access like all the recipes that are for this dedicated ingredient. So I'm gonna create like a table, a recipe ingredient table, like to have both reference on a recipe and on ingredient in order to have access to the data. So to do so, we will be using the via inline function to create the reference between the two data. Okay, now we are all set. Our application can run by itself. I can validate the post request, query my database, send it back. It should be okay. Let's see how we can share some code thanks to Swagger. So we're gonna use the Swagger GRADLE code gen. It's made by Nicolas Corti when he was working at Yelp. It's no more it's supported, but no more maintained. So it's working, but we can improve it. Feel free to open some PRs for improvements. So Swagger relies on Open API for RESTful web services, so made with YAML or JSON format. Generates the RETROFIT interfaces you will be using for your Android application, and it will be generating all the models we will be using both on the Android side and on the backend applications. So it has also a nice support for Kotlin coroutines, and all the models will be generated with Moshi. So like this, we will have a single source of truth between our Android application or client application and backend application. So you're gonna define your Swagger API. So you're gonna define your rules and all the root and all the model definition in your API client.yaml. When you run the script, it's gonna generate all the APIs, all the models you will be using for your applications. So in your GRADLE build, so I'm gonna use the CodeGen plugin, defining the version, and then I'm gonna define, okay, I'm gonna target the Kotlin coroutines to have like a suspend way for RETROFIT. I'm gonna define the package name where the models will be stored. Okay, I'm defining my input file, so the YAML file, and my output directory, which will be in build or wherever you want. Okay, so let's see how we can define the path. For example, okay, this is my new recipe/recipes ID root. It's a get method. It refers to the recipes domain, so I'm gonna put a summary, and then I'm gonna define all the parameters that this path takes. Like for example here, a recipe ID, which is in the path that is required. And then I'm gonna define all the response, like if it's all good, I'm gonna send a new recipe object. And then we're gonna define all the objects that are very typed here, so all the fields that are required and optional. And I'm gonna define all the the format, like, okay, my ID is supposed to be a string with a UID format, my cooking time is an integer, so on. And you can also have some reference. For example, for the recipes, I want to also access to the steps. And it's an array that the items inside this array are a dedicated object. So I'm going to have a reference on the step object. So once you run the GRADLE function, okay, it's good. We have our recipe APIs that we will be using on our Android side. And we have also our like front object for our backend API, which are generated thanks to Moshi. So I have my recipe object with my ID, title, and so on, what I've defined before. The only backfire you can spot maybe when you are dealing with dates, sometimes you have to modify it to like be Android friendly and backend friendly. So that's pretty much it. So Swagger CodeGen will generate the front models for your backend and the remote models for your client application. Like this, you won't have any more surprise. Okay, so the backend change the route, change the data, and it surprisingly break all your application. So here you will have a strong contract between your clients and your API. I did have so many improvements we can do with the Swagger CodeGen. So adding a support for Kotlin serialization, some date type configuration, and so on. Okay, so let's see a live demo. Back to IntelliJ. Still have time? Yes. Okay, so this is like the tiny application I was trying to launch at the beginning. So if I launch this application, so I'm gonna open up the thing. Oh, error. What error? Wow. Okay, no more error. Check. Okay, if I go to like my local environment, it's a hello world. Okay, that's pretty straightforward here. So I was defining like, okay, if I'm on the route, say hello world, and you can go like for this one. So slash JSON. Oh no, I removed the JSON stuff. So it's pretty straightforward, like to have something working directly without any more configuration. But well, this is not really fun to have this. So let's have a look more in detail, like a real web service. So like I said, so I'm defining all these features I want. So here for the data conversion, locations, going for the for the dependency injection, content negotiation for like rendering the JSON, handling the exception, and so on. So okay, let's see how we can define the recipes. Okay, so I want like to get all the recipes. Fair enough. I'm gonna get the page parameter on the request. Then I'm gonna query my service to get all the recipes for a given page. Like this. Okay, I'm gonna call my repository. I'm gonna get all my recipes for a given page. Okay, I'm gonna call all. Okay, this is my gonna get all the recipes, but well, I'm gonna order them and add a limit because we implement some pagination stuff. So I want a dedicated count and from a given offset. Then I'm gonna map this recipe entity we have for our database to an entity, a domain entity. And this entity will be mapped on the front API part to like a view recipe, which is render here. So my recipe gonna be like, it's kind of a mapper here to send the real response to the client. Okay, I will shut down this service and I will run this one. Okay. So I've already opened the connection and launched Docker Compose, so the application is responding. So if nice, the server is running, all good. And for example, if I want to get my recipes, oh, nice, I already have some in the database, so I can display it very easily. It's not very UI friendly, so I'm gonna go for Insomnia, might be too small. So if I want to get all the recipes, so I don't know how to make things bigger here, but you can see all the recipes that are stored on the database. If I want to query a dedicated recipe, for example, let's say get, okay, up, I don't want the steps, but this one. And here, I have like all the detail about one recipe with the steps associated and the ingredients for this recipe. And that's pretty much it. And I can have an example of a new recipe as well, like create a recipe, awesome recipe, cooking time, okay. I think I was missing something like here. I need to check later. And back to the slides. Yeah. Okay. Thank you very much for listening. And if you have any question about Ktor, feel free to ask.